Hello class, in this class we are going to learn ultrasonic testing methods and techniques for forgings. For the common types of forgings, there are many shaft forgings, pie plate forgings, hollow shaft forgings, and rough forgings. When ultrasonic testing forgings, we need to consider the appropriate testing methods. Under what conditions should we use longitudinal wave direct incidence detection, longitudinal wave oblique incidence detection, and shear wave detection? Let's bear these questions in mind while learning the relevant knowledge. Before performing ultrasonic testing forgings, you should be familiar with the process of forgings. Consider the shape and orientation of common defects in forgings, and reasonably determine the best inspection surface and inspection method. In the last lesson, we have learned the machining process of forgings and the common defects in forgings. The detection timing of forgings in principle after heat treatment before finishing process, such as punching and grooving. The main reason is that complex shapes such as holes, grooves, and steps will form areas that cannot be reached by ultrasonic sound beams, increase the detection blend area, and may generate non-defective interference waves caused by complex shapes, thereby affecting the accuracy of detection. Testing after heat treatment is beneficial to find defects generated during heat treatment, such as heat treatment cracks and so on. And next, we illustrate the ultrasonic testing method with specific types of forgings. 1. Ultrasonic testing of shaft forgings. As shown in the picture, in order to find different types of defects comprehensively and accurately, there are 4 main detection methods in ultrasonic testing of shaft forgings. The first is radical detection with a straight probe, which is used in the detection of shaft forgings. When testing, the longitudinal wave's straight probes is placed on the outer circular surface of the workpiece, so that the sound beam is incident rapidly if there is an axial defect on the workpiece. The defect can be detected in an effective manner. When adjusting the sensitivity, the axis needs to be considered. If the diameter is greater than 3 times the length of the near field area of the probe, the bottom wave equivalent calculation cannot be used to adjust the sensitivity. If the diameter is less than 3 times the length of the near field area of the probe, the material, shape, surface, roughness, and sensitivity adjustment is performed on the same test block as the shaft inspection part so as to avoid correction. The second is the axial detection of straight probes. Axial detection is mainly used to find transverse defects perpendicular to the axis. On the end face of the part, a full scan is carried out on the shaft end. If the shaft is long, it should be scanned from the 2 end faces respectively, and the influence of the side wall on the test results should be paid attention to. When the shaft has multiple shaft segments with different shaft diameters, there will be areas that cannot be scanned by the sound beam. So the axial detection of the straight probe has certain limitations. The third is the oblique probe circumferential detection. When the defects are in the radical position and monolithic, it is difficult to find the defects in the radical and axial detection of the straight probe. In this case, the oblique probe is required for circumferential detection. Make the beam incident on the defect as much as possible, or transmit and receive the defect signal through the double oblique probe. When using an oblique probe for circumferential inspection, it is necessary to scan from both directions in a circumferential direction to prevent defects from being missed. The fourth is the oblique probe circumferential detection. When the shaft is very long, there is an uncovered detection area of the detection sensitivity is not enough in a straight probe and face detection. The single oblique probe or double oblique probe tenement method can be used for dictation. The dictation also needs to be carried out from the positive and negative directions. Common frequency of ultrasonic testing for shaft forgings is 2 to 10 MHz, and the appropriate probe wafer diameter should be selected according to the size of the forgings. The commonly used wafer diameter is 520 or 525 probe. In the radical dictation of shaft forgings, tooling can be used to improve the dictation efficiency, and we should select the cooling agent of higher viscosity, and the probe is assembled with a surface adapter block to improve the coupling effect, so as to avoid misdictation due to poor coupling conditions and reduced sensitivity. 2. Ultrasonic testing of pan-shaped forgings. The forging billet of pan-shaped forging is generally made by rough forging of bar or ingot pyre. The forging streamline usually extends along the surface shape, and the defect direction is considered with the metal flow direction. For the pie plate-shaped forgings, the two end faces are the main forging stress surfaces, which can be used as the incident surface of the sound beam. So the vertical wave incident technology is often used to detect the end faces. The center of the pie plate-shaped forging is a concentrated area of defects, which needs to be inspected. When selecting the probe frequency, the roughness of the dictation surface and the thickness of the workpiece should be considered. If the surface is rough and the thickness is large, in order to increase the energy of the incident acoustic wave, a larger diameter of the wafer and a lower frequency can be used. Otherwise, a probe of higher frequency can be used. For the pie plate-shaped forgings with the large deformation, there are streamlines with inclined end faces in some special parts. In addition to the vertical incidence of longitudinal waves, it is also necessary to supplement the dictation with oblique incidence of longitudinal waves of oblique incidence to transverse waves at a specific angle. For important disc-shaped parts, such as turbine discs on aero engines, people often use water immersion automatic dictation equipment and focusing probes. According to relevant standards, Phi 0.4 or Phi 0.8 flat bottom hole test blocks are usually used to adjust their sensitivity, and C scanning is used, mode to scan. 3. Ultrasonic testing of hollow shaft of forgings. Hollow shaft forgings often use the whole forging structure, which is used to manufacture parts that are subject to high pressure operation, so the quality requirements are relatively high when selecting the dictation method. It is similar to the shaft forgings. The difference is that the hollow shaft forgings have near-surface defects due to design requirements. If there are near-surface defects, the dual-element probe can be used for dictation. The main harmful defects of hollow shaft forgings are radical cracks and transverse cracks, which are very harmful. The main dictation methods are circumferential dictation and axial dictation with oblique probes. 4. Ultrasonic testing of rough forgings. The rough surface of the forging refers to the surface of the forging that has not been processed after forging. The rough surface will bring two adverse effects to the ultrasonic inspection. One is that there is a thick oxide skin on the surface and the sound beam cannot enter the workpiece. The second is that the surface roughness is too large and the coupling is poor. The commonly used methods are long-contact electromagnetic ultrasonic method, low-frequency large-diameter focused acoustic beam method, improved contact method. No matter which method is used, first of all, it is necessary to remove the oxide scale and polish the surface to improve the acoustic coupling. When testing, usually select a lower dictation frequency, increase the transmission power to improve the sensitivity, and use coupling agent of the higher velocity to perform the carpet method. In this lesson, we have learned 4 common ultrasonic testing methods for forgings. When we carry out ultrasonic testing of forgings, we must consider the structure of the forging, the production process, the flow line direction of the forging, the type and orientation of the possible defects, wall thickness, machining allowance, and other factors, so as to determine the main dictation method and the auxiliary dictation method. Through ultrasonic testing, the problems existing in the forgings can be dictated. Their laws and properties can be found out. The processing technology can be improved, and the internal quality of the products can be improved in time. That's all for today. See you next time.